Did you have to do it like this?
Wait.
Okay, we did 1, 2, and 5 together. Here are the answers to 3 and 4. People like throw it at the ground. No, it's really present.
Why do you think you did it wrong?
Questions on these two?
How does culture affect the language?
If I need to go back, I will.
The religion one is.
We did 5 together, so look at 6. Questions on 6. And then 7 and 8. So, do me a favor and turn around. Thank you. Questions on those two?
Sydney. Did I tell you to stay? What did I say? Open the shade.
Yeah, it's always like that.
Any other questions on these?
I gave everyone advice. I told my kids to use vegetables.
Alright, so I need side conversations to stop. Thank you. Just to recap everything we've done so far, because this packet is like the last set of notes, which we'll finish when we get back from break. But the first thing of notes was the properties, and that's really 2 different objectives. Your converting and coterminals, your arc length, area, sector, angular, and linear speed. The second thing of notes was really your third objective, solving triangles, solving sides within those triangles. The third set of notes was your unit circle stuff, which is your 4th objective. 5th set of notes was this stuff. 4th set of notes was this stuff, but that's your 5th objective. Finding your trig values for any angle. And then your 6th objective, which is these last set of notes, is graphing trig. So, like I said, we're not going to do a lot of this today. I just want to talk vocab, really. So just like with any other graphing function, we need to remember the types of transformations. So if we have some negative outside of the function, what type of transformation would that be? Vertical. Reflection, yes. You don't need to write this part, you can, or reflection over the x-axis. So this would be horizontal reflection. Or a reflection over the y-axis. Anytime we are multiplying some number outside of the function and that number is greater than 1, what would that be? Vertical stretch. So then this one, if it's between 0 and 1, would be vertical compression. Remember that your insides, your x's, they don't do what they're supposed to. So if this is multiplying inside, but the number is greater than 1, what type of transformation is this? It is horizontal, but it's not a stretch.
Wow.
So they don't do what they're supposed to. It's greater than 1, so here it was a stretch. Here it would be a compression, because really we're multiplying by the reciprocal. So that means this would be our stretch. And then if we are adding or subtracting something inside, what type of transformation is that? So this one. It is a shift. This would be right.
Right.
So remember, it does the opposite. It has a negative, and you think it's going to go negative, but it really does the opposite. It goes right. And really, that's because there's a negative h in there already. So this is left. And then if you were adding or subtracting something outside the function, it's a vertical shift up or down. So we need to remember those basics. So when you see different graphs with different pieces everywhere, you know what's being applied, what's changing. Now, those are going to happen, but some of the vocab we're going to use is going to change a little bit. So instead of horizontal shifts with trig, these are now phase shifts. So anytime we have a phase shift, it's been shifted horizontally. This is our midline, and you'll see more about that when we get back, really, because we're not going to get too much into that today. But anytime we have a vertical shift, the midline is affected by it. So we can find our midline by using y equals k, so whatever our k value is, if it hasn't been shifted at all, is 0. And then if it has been shifted up or down, it will change what that midline is. So when we're graphing, or when we get to graphing, when we draw our midline, it's going to be the middle of really just a couple of our functions. But you'll see that when we're graphing. And then this one is our amplitude. So vertical stretches and compressions are affected by your amplitude is affected by that. But it's talking about distance. So when we graph our sine and cosine functions, they're going to repeat themselves over and over again, going up and down, having minimums and maximums. And that midline, you're going to measure the distance from that midline to the minimum or maximum. I did that backwards. But so because we're measuring distance, this has to be a positive value, even if it has a reflection. So the reflection could still happen, but the amplitude is going to be a positive number. And then we know that on the unit circle, we could keep going forever and ever in the positive direction or forever and ever in the negative direction. I think I did that backwards. So there's infinitely many angles in both directions. So that means these are going to repeat themselves often. Every time it repeats itself, it's a period. It goes through a period of these intervals. So the length of this is a period. And your horizontal stretches and compressions affect this. So if you have a horizontal stretch or compression, it may affect how long it takes to repeat itself again, or how short it takes itself, if that makes sense, to repeat itself again. But this is found by 2 pi over b, over the absolute value of b. So in general, if we have no transformations at all, those would be your sine and cosine functions. You don't have any a's, any b's, h's, k's, no transformations at all. But if you have any of those, then you change that format to add those in. When you look at your sine function and your cosine function, they almost look the same. They just start at different places. These are actually really the same, just one has been shifted. So if I move this to start at 0, it would be the same weight. So on the next page, it says that the cosine function is really just a shift of your sine function. That makes these sinusoidal functions.
What?
Sinusoidal functions.
Why is
So how do you spell that?
Sinusoidal. Sinusoidal.
Oh, it's sinusoidal.
Because really they're both just sine functions. They're really just both cosine functions. So they're really just the same thing. They've just been shifted.
Where does the soul come from?
I didn't make the word. So anytime you have just a shift of your sine function, so really just sine and cosine apply here, those are sinusoidal functions. Now, we know that our unit circle repeats itself, so we're going to keep going around the unit circle. It's going to keep going and going. So that means each of these functions is going to keep going, which makes them periodic functions. They're going to keep repeating the same period of 2 pi over and over again. But that also applies to your other 4 trig functions. Secant, cosecant, tangent, cotangent. Those are periodic functions as well, because they keep repeating around the unit circle. We're going to do this part when we get back. I just want to show you guys 2 things.
Actually, I don't know. This is good.
So for this,
Look at that.
as it's going around the unit circle, it's taking each of the values and it's making this sinusoidal function. So every time it goes around, it's just repeating itself
What
again
website is
and again and again. Math is fun.
Math is fun. No.
We also have Okay. So you're actually going to get to see that once we actually graph it, but just keep that in mind. Disregard this guy's face for 2 seconds.
Oh, it's when you see the little waves thing.
I started it.
Oh! I've seen this before. I love the Mexican food. I want to go back. My mom doesn't do that.
So most of the time I get the question, when will we ever use this in real life? So so sinusoidal waves are used in real life for sound waves, other things too. Can you think of anything real life that uses sinusoidal waves? Ferris wheel? Explain. So you're talking about like the actual,
If you look at
like
the position,
the position and
the C,
sorry, say it again.
the C, actual weight.
Actual waves. Okay. I heard a heart monitor. Yes. It's not as sinusoidal. They're more pointy, but radioactive waves.
Microwaves.
Radioactive waves.
Microwaves are radioactive. You said microwave? What? She said microwaves are radioactive waves are two very different waves. Radioactive waves are
anyway.
but then you put it on the glass.
Exactly.
I think someone yesterday said lights. She'd have to explain it again. Something about from lights. That's I don't know. I don't remember what she said. But it is used in real life.
So when you're in a crowd, everybody has to wait.
So physically, okay.
Yeah.
So
Oh,
that
wave pool.
physically. So that's all we're doing today.
I mean,
Watch it again. No, pull up the Christmas website.
Hey,
Oh, we
gotta
make
make
a
a
Christmas
game.
tree.
Yeah, you know the one that like
you guys can do that.
on your smartboard.
Demo ready?
We can make it on the